size of my training set, right? So the m there is my number of training examples, right? That hash sign is the abbreviation for number of training examples, okay? And to make some of our later math a little bit easier, I'm going to actually look at 1 over m
is a
times
demonstration
that. So
of
I'm going to try to minimize my average error, which is going to minimize 1 over 2m. Putting the 2, the constant, 1/2 in front, it just makes some of the math a little bit easier. So minimizing 1/2 of something, right, should give you the same values for the parameters theta 0 and theta 1 as minimizing that function. And just to make sure this equation is clear, right? This expression in here, h subscript theta of x, this is our usual, right?
This
That's
is a demonstration of Wirecast.
Theta 1 xi. And this notation, minimize over theta 0 and theta 1, this means, find me the values of theta 0 and theta 1 that causes this expression to be minimized. And this expression depends on theta 0 and theta 1. Okay? So just to recap, we're posing this problem as, find me the values of theta 0 and theta 1 so that the average, or really 1 over 2m times the sum of squared errors between my predictions on the training set minus the actual values of the houses on the training set is minimized. So this is going to be my overall objective function for linear regression. And just to rewrite this out a little bit more cleanly, what I'm going to do is, by convention, we usually define a cost function, which is going to be exactly this, that formula that I have up here. And what I want to do is minimize over theta 0
This is a
and theta 1,
demonstration of
my
Wirecast.
function j of theta 0, comma, theta 1. Where, just to write this out, this is my cost function. So this cost function is also called the squared error function, or sometimes called the squared error cost function. And it turns out that why do we take the squares of the errors? It turns out that the squared error cost function is a reasonable choice and will work well for most problems, for most regression problems. There are other cost functions that will work pretty well. The squared error cost function is probably the most commonly used one for regression problems. Later to our data.
This is a demonstration of Wirecast.
In linear regression, we have a training set like that shown here. Remember our notation, m was the number of training examples, so maybe m equals 47. And the form of our hypothesis, which we use to make predictions, is this linear function. To introduce a little bit more terminology, these theta 0 and theta 1, right, these theta i's are what are called the parameters of the model. And what we're going to do in this video is talk about how to go about choosing these two parameter values, theta 0 and theta 1. With different choices of the parameters theta 0 and theta 1, we get different hypotheses, different hypothesis functions. I know some of you will probably be already familiar with what I'm going to do on this slide, but just to review, here are a few examples. If theta 0 is 1.5 and theta 1 is 0, then the hypothesis function will look like this, right? Because your hypothesis function will be h of x equals 1.5 plus 0 times x, which is this constant valued function that's just flat at 1.5. If theta 0 equals 0, theta 1 equals 0.5, then the hypothesis will look like this.